Okay, as a precursor to our pollution, we're going to talk about risk assessment and risk management. And then we'll talk about our first really global pollution problem, which is global climate change, which we've talked about a lot, and we'll talk about more in class and some of the science behind it. But first, let's talk about risk. So, a great example of this is the outbreak which occurred in 2014, spread into 2015, of Ebola. Ebola is a very contagious disease and a very deadly disease. Not very many, I think it's somewhere around 50% of the people who contract it end up dying. It's a very painful process. And so this outbreak in Africa, there've been a number of outbreaks, but this last one was had a lot of concern as to how fast it would spread. And it started in Africa, in these central Western African nations, and had some cases in the United States. Eventually, it was contained, and now there are no more Ebola cases, and it's not spreading. But it has the potential, this and other diseases, to cause a lot of death as these viruses mutate and become more transmittable and more deadly, which may or may not happen. But it did show that we are quite connected to our environment, especially in concern with diseases and the spreading of disease. And with diseases, we have this new globalization where we can go from one point to the of the earth to the other in less than a day. We have products going all over the world, food going all over the world. So the spreading of human contact is ubiquitous, and you really can't escape it. So environmental problems in Africa then can become environmental problems in the United States or Russia or South America, and vice versa. And so there are a lot of cautionary procedures that need to take place, and risk assessment, or what we're willing to do, how open we are going to be with our globalization, and the restrictions we're going to put on those sort of things, is infused into many of our practices, especially environmental policies. Okay, so we can sorry, I'm trying to get to my presentation. We can break hazards down into different categories. A cultural hazard, and this isn't really an environmental hazard, but these are hazards influenced by human choice, such as choosing whether or not to smoke or whether or not to exercise, those sort of things. Biological hazards mostly include our diseases, our infections, and parasites. And some examples of diseases include tuberculosis, AIDS, and malaria, which are still very prevalent in the world. Our physical hazards include natural disasters, and our chemical hazards include products of industrialization that then or byproducts or waste, which is then dumped into the environment at some point, or needs to be stored, or maybe we are just naturally exposed to different chemicals. And all of these are hazards and assessments, which assessments need to be made on these hazards and their exposure. So one of the things, so this here is a life cycle of malaria. Malaria is not found in the United States. It was historically, but we treated the mosquitoes with DDT quite heavily to get rid of those mosquitoes. And now malaria is, we almost, or there was an effort to eradicate malaria worldwide. However, we weren't able to kill all the mosquitoes that carry it. This is a blood-borne disease and also causes extreme sickness and death in many parts of the world, especially tropical areas. So some of the risks which expose you to these environmental hazards include poverty, and the world's number one risk factor is underweight. If you are poor, you are at risk of being underweight because you do not have access to food. Poverty also makes you vulnerable to other risks, including disease. So poor people generally live clustered together. They generally don't have safe drinking water. They are suspect to environmental hazards being dumped into their waterways as well. So poverty is something which makes you at risk for those hazards we just talked about. Cultural risks, like we said, tobacco use is the number one cultural risk which causes death, kills half of its users, and it's also responsible for almost 30% of cancer deaths. And secondhand smoke as well causes a lot of deaths per year. So infectious diseases, on top of they being a risk, are also more prevalent in our developing poor countries. So even when you look from one country to the next, our poor countries are the ones who have more of these infectious diseases because of inadequate sanitation and infrastructure. The tropical environment is just more conducive to many of these diseases, has a diversity of diseases which are spread quite easily. Malaria is currently trying to be treated through the use of DDT and nets in Africa and Asia. And there are some of these very poor countries which are increasing the use of these in smaller doses than we did in the United States, because DDT is a harmful product to the environment and to human health. So again, there's a risk assessment being done here with malaria. Is the risk associated with DDT more or less than the benefit that could come from eradicating mosquitoes and preventing malaria? When talking about toxicity, especially with chemicals, you can have a chronic exposure, which is over an extended period of time, and generally this is small amounts, and this is very actually prevalent indoors with indoor air pollution. Acute exposure to toxic chemicals usually occurs through some sort of accident where something is spilled, or is not generally we aren't generally exposed to large doses of things. A carcinogen is something that causes cancer, and lots of things cause cancer, but carcinogens are more so than just everyday exposure to things. So we are exposed to a lot of things indoors, and indoor air pollution is a lot of times more a greater risk than outdoor air pollution, depending on where you live. But there are a lot of things that can cause a biological or chemical hazard. So we have natural radiation, which occurs just through things breaking down in the dirt surrounding our homes. You may smoke. You may have cleaners and things, or paints and things, pesticides. You're exposed to these things if they're in your house, and if they aren't dealt with appropriately or with proper ventilation, then your indoor environment can be very toxic. So disaster risk is something which I find kind of interesting. I want to live in a place where disasters are not frequent and not considered at risk. However, no matter where you are in the world, there is something that is going to possibly happen as far as a natural disaster. So places that are particularly prone to natural disasters are places that are next to the water, right? Because you can have a hurricane, you can have a tsunami, you could have flooding, but most of our habitations also live next to water because we need water for many of our processes to sustain life. So to reduce the risk of disaster, you need to make it a disaster risk reduction a priority. People should know the risks and be able to prepare for them. So if you live in an earthquake-prone area, you should have earthquake-safe houses. That goes along with building understanding and awareness of the risks in which you live. And then find ways to reduce risk. Maybe live not in the floodplain, or not build houses so close to waterways. And then once they happen, there need to be mechanisms in place to prevent, large-scale death and damage. Great example of this is Hurricane Katrina. A bad example where they weren't prepared, they weren't ready to act, the levees weren't built to sustain that kind of hurricane, and so it was really that tragedy was waiting to happen. And again, the poor are disproportionately affected. The poor can't mobilize as well in an evacuation. They generally live in not as structurally sound housing. Countries that are poor generally are also those that are very prone to natural disasters. So disaster on top of being poor is double risk. So risk assessment then is the process of evaluating the risks with a particular hazard before taking an action in which the hazard is present. And we do this kind of in our everyday decisions. Is drinking alcohol a risk we're willing to take if there is a chance we could become an alcoholic? Some things we do not have much control of, including poverty, especially if you are in those lower, or you have less of a privilege in your income. And then some things we do have greater choices over. But each of these then can, on average, lessen your life expectancy. And we make those choices every day. So risk management then is looking at those risks and doing some sort of cost-benefit or plus-minus analysis. Cost-benefit analysis then looks at the cost. It usually has to do with the regulatory mechanisms involved for allowing or not allowing specific procedures. Risk-benefit is similar, comparing the risk to the benefit. An example of this is CT scans, which expose patients to a large amount of radiation. But if there is a trauma or some event such as like cancer or something, the benefit of getting a scan outweighs the risk. However, more and more scans you do, the more exposure you have to radiation. So at some point they may say, oh, well, we can't do a CT scan because you've had too many in the past year or something. Interesting thing about risk management is the public in a democracy has a lot of sway as to what is an actual risk, well, not what is actual risk, but what policies are implemented based on our risks. People are more likely to follow policies that are based on public opinion. So basically ones that they have chosen are felt to be appropriate, as opposed to ones that are being mandated, which causes a problem because the public aren't always the most educated in those. And that's what causes this sometimes outrage against hazards. So, for example, if you are addicted to cigarette smoking and now it's illegal to smoke almost anywhere, well, that's because of the risks involved with other people. That still might cause outrage, right? So, some of these things that cause outrage include a lack of familiarity with the technology involved, the extent to which the risk is voluntary, again, the public impressions of the hazards. So global warming is a great example of this. The public impression is mismatched against what actually might occur. Overselling of safety. So sometimes I think this is kind of like the mom and dad effect, basically. Mom and dad are constantly reminding their kids, okay, you can't do this, you need to be safe. The kids kind of blow it off because they don't see it as big of a deal. The morality of the hazards and the implementation of policies can also have an effect. Fairness. So a good example of this is in Flint, Michigan, with the lead in the water. That was not dealt with very justly, and it was not fair. If the same things happened in a richer, more affluent neighborhood, or racially divided as well, so in a more white neighborhood, then things probably would have occurred as far as what they would have done with the water, probably at a much faster rate or had much faster response. Solution to most of this then is, well, we should kind of err on the side of caution, right? Have a precautionary principle, and not just go with the public outrage. This is hard to do, though, because it also gets very political as well. All right, so with all that, we have to use these risks assessments with pollution. Pollution occurs over our air, water, and land, and our biospheres, right? The living things within them kind of connect our three biospheres: air, water, and land. And everything we do adds to pollution to the environment. Okay, whether we are buying something from the store, that product has an environmental effect, right? We drive to the store, well, that gasoline, its refinement, its drilling, all that had an effect on the environment and our continued use of it as well. So we decide what activities, what pollutants are worth the risk. We go through a risk assessment as a society, and much of that is based on the science behind, what environmental pollutants do, and what we can do to prevent them. All right, so some terms on pollution. Pollution is the presence of a substance in the environment because of its chemical composition or quantity, presents the functioning of natural substance processes. So basically, something that causes an alteration in the environment. A pollutant is anything that causes pollution. Many of them are non-biodegradable, meaning they don't break down in the environment and they persist and accumulate. The environment is our physical, chemical, and biological setting of where and how we live. A hazard, which we talked about before, anything that causes injury, disease, or death to humans, damage to personal public property, or deterioration or destruction of environmental components. The risk is based on a probability of being exposed to those hazards, suffering injury, disease, or death. Vulnerability is the degree to which a person is at risk, so our poor are more vulnerable. Morbidity is the incidence of a disease, and mortality is the incidence of death in a population. So, in context now, we're going to talk about global climate change. This kind of says it all. I was going to kind of list out some questions, but this is really the underlying issue with global climate change. The actual consensus among climate scientists is around 97% that humans are causing global warming. Nobody's really denying that global warming exists or that global climate change exists. Maybe some people are. Really, what appears to be a debate is whether it's man-made or just natural. Now, so this is the scientists' a general consensus. This is the public. 55% mostly agree or know that scientists largely agree. 45%, however, don't know or think that the science is divided. Um, and this is what's causing the inaction, or at least part of the problem of the inaction of global climate change. Now, global climate change is a kind of a complicated scientific study, but some of the basics of it are we do have solar radiation, which some of which is pointed towards the Earth. As it points toward the Earth, we have an atmosphere filled with different things, which is going to cause radiation or reflection, and so a lot of this sunlight is reflected back out to space. A lot of it is absorbed generally at the surface, and as it's absorbed, some of that is radiated into the atmosphere as well. And then a lot of that heat is also absorbed by oceans and creates convection and evaporation. These are processes which fuel our weather and ultimately our climate. So our weather is our day-to-day variations, so it's day-to-day, not today, in temperature, wind, humidity, and precipitation, whereas climate is our long-term pattern. So we live in a seasonal climate in Virginia, but the weather today is high of 45 with a low of 24 or something. Meteorology then is the study of the atmosphere, including weather patterns and climate. A troposphere is a layer of the atmosphere in the lowest part, and this moderates the flow of energy to Earth and the biogeochemical cycling, including our water cycle. Stratosphere is above the troposphere and increases in temperature up to 40 miles. It also contains ozone. The tropopause then is the boundary layer between the two, and the stratopause is the upper boundary layer of the stratosphere. So this is what it looks like. This is where all our weather patterns that affect us occur. We do have the ozone layer in the stratosphere. The stratopause is above that, and the tropopause divides our stratosphere and troposphere. Okay, and there are variations in the temperature as you go up. It gets much colder, and then above our ozone shield, we have another warming period in the stratosphere. The oceans and the currents are a major sink for heat. Also, carbon dioxide dissolves into the ocean, and so a lot of the effects of carbon dioxide and global warming are buffered by the effects of our ocean. But they help also to distribute this energy and carbon dioxide throughout the world. So greenhouse gases then are gases in the atmosphere that trap heat and emit some of it back into the atmosphere and include carbon dioxide, methane, and even water vapor. Planetary albedo is sunlight that is reflected before it hits the Earth, and so it doesn't warm the Earth. Most albedo is caused by cloud cover. Some, however, is caused by aerosols, which there are naturally occurring aerosols, but there are also artificial aerosols. Aerosols actually have a cooling effect on the Earth. All right, so now some of the evidence. I'm just going to list this. I'm sure you've heard this before many times over, but rising sea levels are indicative of melting sea ice and glaciers, and also continental ice on Greenland and Antarctica. We have direct measurement of ocean temperatures. We have land temperatures as well. We have changes in weather patterns, more intense weather, increases in carbon dioxide in the ocean, and changes in animal distributions and changes in climate. So here's some of that data. This is heat content. This was originally produced and then had to be altered. As you can see, the the this is looking at temperature change, and 0 being the average. And you can see there's an increase since the early 1950s when they started taking this data directly. This is looking at global sea level, which you can see has obviously increased in millimeters. So since 92, we've had a 60 millimeter increase, which doesn't seem like a lot, but it is significant. Global surface temperatures, again, 0 is our mean over the whole time period here. In the last 40 years, we've had a steady increase in mean surface temperatures. Here is a glacier. You can see the glacier has retreated. This is the same area, same picture. And the melting of the glacier is increasing more each year. This is the original sea ice in the Arctic in the red, and current sea ice. Sea ice is continuing to decrease, which is not actually increasing sea levels in and of itself, because this ice is already in the water. But water is also expanding as it warms, so that thermal expansion also causes an increase in the sea level. And here's a graph showing the Arctic sea ice and how it's diminishing. So the big cause to this, or part of the problem, there's a lot of things again, but one of the big contributors, I think almost 30% of global climate change, is the emission of these greenhouse gases, including carbon dioxide. Now, North America has reduced, well, it hasn't reduced, but is now, if you slice this up, you could show that the U.S. is a big contributor here, and then China would be a big contributor with Asia, and China is actually contributing more in carbon emissions than the U.S., but those are the two biggest polluters of carbon dioxide. What this has done is created a change in our climate, and there have been models as to what is this going to mean, and these are a few dated models, A1b, A2, and B1, and we won't really go over these, but the big thing about it is you're starting to see a change in scenarios as to where our climates are going to be, which is going to have a lot of ramifications as to where we grow food and how we grow food. So Indiana, by mid-century, its climate will have shifted down, or we'll have a climate similar to Mississippi by mid-century, and then similar to Texas. These are different projections with a lower and higher emissions scenario. Michigan as well will have something similar to lower Tennessee, Ohio, and then down into Missouri, or in, again, similar to Texas, Oklahoma, which is not going to be good for the environment there. And what we have here is a climate gap, right? To actually significantly reduce carbon dioxide emissions, which is going to take a considerable effort, and really this blue line is where we're headed if we continue to do what we're doing. We have had recent climate meetings in Paris where there were a lot of pledges made. However, the U.S. seems to be backing out on a lot of those pledges because of our new administration. This is what is going to happen. So here's where we are right now, an increase of less than a degree, just barely. But we're starting to see a lot of these things happen. Our polar ecosystems are being damaged. The amphibian extinctions are increasing, especially in mountaintops. If we get up to this 2.5 degrees, we're going to have major losses of the rainforests. it's just not looking good for the environment if this continues. So our options are, well, let's mitigate the effects. So there are a lot of different things we could do for that. We could do a cap and trade, which is going to reduce carbon dioxide, basically give us a nudge similar to our carbon tax, where you have an economic kind of push towards reducing carbon dioxide and increasing alternative energy and nuclear power. We could also try and sequester this carbon dioxide and store it somewhere so it doesn't have an effect, or reforest areas so that there's more carbon within the plants, less in the atmosphere, and also reduce our population growth. These are all mitigation efforts. Let's reduce carbon dioxide, but we're already going to have to adapt, and it depends on how much the mitigation factors are going to affect how much we're going to have to. So we're going to have to shift our agricultural areas because of the warming. We're going to have to reduce risks, establish a financial safety net for the poor, especially who are going to be significantly affected by this. We're going to have to also control for diseases, which are probably going to be much more transmissible, such as Ebola. So our response then to global warming is going to have to combine these mitigation and adaptation responses, and it's going to be more and more evident for our children and grandchildren than it is for us, but something should be done immediately. All right, we're going to talk a lot more about this, including the science, how do we know what we know in class, and hope you had a great spring break.